Hey guys, Mr. B here. In this video, we're going to be doing some practice problems with work and power just to show you how this whole thing works. All right, so let's begin here with number one. So it says how much work is done when an 8 Newton force moves a block 7 meters. Now it does give us the equation for work up above, so you know that work is equal to force times distance, okay? And in this problem, 8 newtons of force is given. So this is going to be equal to 8 newtons of force times our distance in this case is going to be 7 meters. So this one's going to be pretty straightforward. We'll take 8 newtons, multiply that by 7 meters, and we will get a work. So let's see, 8 times 7, we get 56. And of course, the units for work are joules. So 56 joules of work will be done. We'll underline this to show that that is our answer. Okay, there we go. Pretty simple. All right, let's begin here. Let's go into number 2. Eva applies 40 newtons of force to move her bookcase 3 meters. How much work did Eva do? All right, so same thing. We know that work is equal to force times distance. And in this problem, they are giving us 40 newtons of force, and they are giving us 3 meters of distance. So 40 newtons times 3 meters. And again, I'm doing this on a calculator just to make sure that I don't mess up. And we get 120, and since it is work, the units of work are joules. 120 joules of work. All right. Number 3, how far will 490 joules of work how far will 490 joules of work raise a block weighing 7 newtons? All right, so now, again, we still know that our equation for work is force times distance, okay? But in this problem, they're giving us work, and they're giving us force, but they're asking us for distance. So basically we have 490 joules equals 7 newtons times distance, okay? So we get to here. Now, how do we solve this one? Because we basically have this variable of distance on the right, and in order to solve for distance, we need to get this variable by itself. So we're going to have to do a little bit of algebra, okay? So remember how this is going to work. In order to get the variable distance by itself, right now it's being multiplied by 7 newtons. So we need to get rid of this multiplication on the right side. To do that, we need to do the opposite of multiplication, which is division. So we are going to divide, okay, we're going to divide this whole side by 7 newtons. And if we do that, that will cancel out this 7 newtons with this 7 newtons that we just wrote. Now, if we do that to the right, we also have to do it to the left. So we're going to divide this side also by 7 newtons, okay? So we do that, basically we're going to have 490 joules divided by 7 newtons is equal to distance. All right, so on the right-hand side, these units of 7 newtons will be gone. We just have distance left. And on the left, we have 490 joules divided by 7 newtons. If we do that on a calculator, we will get a distance of 70 meters. So distance will be equal to 70 meters. Okay, and there we go. That's how we solve that one. So there may be some problems where you have to do a little bit of algebra, okay, in manipulating your equation, but hopefully you're able to do that. So, all right, number 4, it says Sheila did 110 joules of work to move a chair 2 meters to the right. How much force did Sheila use to move the chair? All right, so this is going to be like the last one where we have work is equal to force times distance. They're giving us work, which is 110 joules. They're giving us a distance in this case, which is 2 meters, and they're asking us to solve for force. So it's like this one we just did, only now we're asking to solve for force rather than distance. But regardless, we need to get this unit of force by itself, and it is being multiplied by 2 meters. So to get rid of that, we need to divide by 2 meters. Okay, so if we divide the right side by 2 meters, then these will cancel out with each other like this. And again, if we do it to the right side, we have to do it to the left side. So we're going to need to divide 2 meters to the left side as well. So basically, we'll have 110 joules divided by 2 meters is equal to force. Okay. And again, we'll do this on our calculator to make sure we get the right answer. So I get that force is going to be equal to 55 and the units will be newtons, okay? Because remember, the unit for force is the newton. So 55 newtons is how much force Sheila will have to use to move the chair. Okay, number 5. Which is more work? Pushing with 115 newtons over 15 meters or lifting 20 newtons over 10 meters? All right, so again, we know that work is equal to force times distance. So in the first example, we have work is equal to 115 newtons times 15 meters, which is going to be equal to, so let's see here, so 115 times 15 equals 1,725 joules of work for the first example. So we'll say this is work for number 1, which is this first example. And then work for number 2, so work for 2 is going to be 20 newtons times 10 meters. Okay, so 20 newtons times 10 meters, 20 times 10, there we go, is only 200 joules of work. So which is more work? We'll say that pushing, pushing 115 newtons over 15 meters is more work. Okay, because that requires 1,725 joules of work versus the 200 joules of work. All right, number 6, how much power does it take to do 500 joules of work in 10 seconds? All right, so now we have a power problem. Okay, now power is given up here. Power is work divided by time, which is also force times distance divided by time. So we know that power is equal to work divided by time. And in this problem, our work is going to be 500 joules. Our time is 10 seconds. Okay, so 500 joules divided by 10 seconds will give us our power, which in this case we are going to get 50. And the units of power are watts. Okay, so 50 watts of power will be generated. Number 7, how much power does it take to lift 250 newtons, 40 meters high in 2 seconds? Okay, so we know that power is equal to work divided by time. They're not necessarily giving us work in this problem, though, because remember, work is measured in the units of joules. They're not giving us anything in joules. But we know that work is so we know that work is equal to force times distance. So what we can do is we can first solve for work by taking our 250 newtons of force times our distance of 40 meters. Okay, so we can find our work first. So 250 times 40. So that is 10,000 joules of work. And then once we have that, we can take then our power equation and go that power is equal to 10,000 joules of work divided by 2 seconds of time. Okay, because power is work divided by time. So 10,000 divided by 2 seconds equals, and this is going to give us a power of 5,000 watts. Okay, so that required a little bit extra to do that one, but not too bad. Our last question, it says, if it takes 20 newtons to move a box, how much power will be needed to move the box a distance of 5 meters in 5 seconds? All right, so this is like the previous problem where we know that power is equal to work divided by time. They're not giving us work in this problem necessarily, but they are telling us a force and distance. So first we're going to have to calculate work, which is force times distance. And we know that our force is 20 newtons and our distance is 5 meters. Okay, so we're going to calculate work first, which 20 times 5. So we are going to get 100 joules of work. And then they do give us a time of 5 seconds. To find our power then, we'll take our work, which is 100 joules, divided by our time of 5 seconds, and that will get us our power. So 100 divided by 5, and we will get a power of 20 watts. Okay? And there we go. That's it. So that was all 8 problems. Hopefully that gave you a little bit of clarity on how to do these types of calculations. But of course, as always, if you have any questions or need any help, make sure that you reach out and ask. All right, guys, that's it for this practice video. I'm Mr. B. I'll see you in the next one. Bye.